Hello everyone and welcome back. In the last video, we created function declarations for list operations. We also added them in our command handler class. So we have common commands, ping, echo, and flush all. We have key value operations we did before, set, get, keys, type, delete, expire, rename. Then we have list operations, only the handlers for length, list length, list push, RPUSH, LPOP, RPOP, LREM, LINDEX, LSET, and they are all being processed in the process command function. We are checking for common commands, key value operations, and list operations. We all added this in the last video. And we also did a lot more in the previous videos, but if you haven't seen them, I cannot even explain right now. So I guess this video, because we already had our list operation declarations, so we can start making the bodies of these functions in the C++ file. And you can see how they will look kind of in the header file, but the magic will happen in the bodies, of course. So we already have a use cases file that we were talking in the previous videos. And we will just basically implement these comments and make them work. So let's go. I am going to my C++ file. We can just copy the names for now and paste it here with some space. And we will need to have the class name in each, so I will just copy and paste them quickly. Okay, now I will say Ctrl D. Okay. I think this is how they will all look. I don't see any error, so yes. Let's start with list length. So you can see why we are using it. You can always check the documentation to see why they are existing and like how they work and what they're supposed to return. I will not talk about them too much. I will just be focused on showing how I implement them, because it's already taking so much time and I don't want it to take forever. But we will have some concepts we used in the previous videos. We will have a lock guard, so we will have mutex because we are planning to have multiple clients at the same time, and we don't want them to clash with each other and make everything work as fun as possible. So we are starting almost every function with the mutex. I guess every function, maybe not every, but most of them, I guess. And I can even just copy and paste this to all of them, even now, because why not? Okay, so back to L length. We will be iterating to our list store, which is an unordered map. If you remember the previous videos, where is it? Here. We have unordered map list stores, which has a key value, string, and a vector inside for the list. And in this L length, we will check the number of items and return a size t value. So we will say find the key in our list, and if the list store is not the end, then we want to turn the size of the whatever in the values in the list, and if it won't work, we will just return 0, showing there's no value in the list. So first one is done. Let's go to LPUSH, which again have the same log guard mutex for safety and consistency. And this time we will have we will insert a value in our list. So I will say list store in the index of the key. Let's insert an list store key where we begin and the value we want. Okay, why we do this? Because I want to show you the difference between LPUSH and RPUSH. So again, let's do the same for the LPUSH, then I will say the difference. So in the key, we will be pushing back this time, not inserting. Again, this is the same. So I will say list store, and actually, no. We will just push back the value. Okay. So in the first one, we are adding an item to the list. We are using LPUSH. So we are adding high priority task at the beginning. So we are getting where the list store begins and adding our value, inserting it. And RPUSH just appends regularly, so I am just saying pushback, which will add our value and the end of the list. So this is the difference, and they're actually quite simple. So in the LPOP function, you can check what is the use case, or you can always check the Redis documentary. It's quite good. And this time we will having our list store, and we will find a key, and we will be removing that because it is removing items from a list. If you want a task from the beginning, you say LPOP, or if you want to remove the last, you say RPOP. And so LPOP will be checking to find the key, and if it is not store and, so it means it is there. And also if it is not second, if it's not empty at the second place, so we will say we are just checking if our key is existing or not. We will say value it's second, and front. You can always check what are they doing if you are not sure. Just return the data difference, so the data of the first element. So we are getting the front as our value, and we are saying second that raise, and then we are giving it the begin. If all goes well, we will be returning true, or we will just returning false. Okay. This is how we remove the first index or from the top. Now let's do the RPOP, which is very similar. I can even just copy and paste, I guess. We just need to modify some parts. This time when we say find the key, and after checking if it is existing or not, we are checking if the second is in the back, because in the first one it will take from the beginning. So we say front. Now we are looking for the back, and if the second, when we get the value as our from the back, we just say second dot pop back, and then we return true or we return false. LREM is a little bit more confusing because we need to remove a specific element from the list. If you ever had experience with linked list before, it's not so much fun, but you gotta do what you gotta do. So this time we know the key, the count, and the value. So we have an extra count value here, variable. I will have another variable, say int removed, and we will be returning removed when we are done. And again, I will say get it, and this time in the list store we will find the key just like others, and we will be checking if the key we found is valid. So we will say list store, and it's not the end, so it means it will work fine. If that's the case, we can just return, because it is not what we are looking for. And we will have a list, which will be its second. And we will need to remove the specific element and its occurrences, like duplicating or a cancelled task. So I wish we left it for the last one, but okay, let's do it. So first I will check if the count, the one we are getting from the command handler, if it is 0, it means remove all appearances. Else, if it is not, not 0, then it means remove from tail to head. I mean, count is negative. So we'll be iterating over the list, of course, if you didn't get it by now. And let's talk about how we will be removing all the occurrences. And I will first be saying what is our new end will be look like. So I will say, let's remove the let's remove something in begin and the and value. I guess we need to include another library, algorithm. Yes, the move function comes from the algorithm. Okay, as you can see, we have the iterator input and the value to be removed, and we just fill what they give us, and we will say removed will be the distance between the new end and end of the list end, and then we will be erasing end and also list. So to explain, basically we are getting the new end we want to have, and we are just removing everything, and removed will be the, because you know we are, when we say remove, okay, that's actually really good. We are removing the first count occurrences of the element, and we are checking for the count number. If it is larger than 0, we are where is it? So first we have if it is equal to 0. In that case, we are removing all elements, and we will have an else if. Why does it look bad? Okay. And else if we'll be checking for if the count is larger than 0. And if it is, the other else will be for the negative cases. If it is larger than 0, we will just remove the elements equal to element from moving from head to tail. So remove from head to tail. And if it is negative, we will just move from tail to head. That's just how the function works. We are just trying to implement it. And it will return the number of removed elements. So that's why we have removed. And we are saving it in the distance between new and old. So we will know how many of them removed, so we can return the number of removed elements. So like I said, if count is larger than 0, we will have a for function, because now we will be checking in a direction and we want to check it until we are happy, I can say. So list begin, and we will iterate till list is ending, or removed is large enough, so nothing to remove. We don't have any other. Yes. We will iterate to the list. So I will say iteration for iter is, if it is the value, the pointer to iterate the list, we will say iter is equal to list remove erase, and which will erase the iter, and we will say, okay, we removed one, so we can increment removed by 1. If it is not equal to the value, we will say, okay, let's skip to the next one, and we will just increment the iterator by 1. Okay, we have the if count is 0, if count is larger than 0. Now we are going for if count is negative. Again, we will have a for loop. I will say auto reverse iterator, because here we said iterator. Now we are going for reverse direction. Reverse iterator equals to list of not begin, reverse begin. We will go to the reverse direction from tail to head. And if the reverse iterator is not the end, and also removed number is not more than the count, but in the minus, because we have the -1 right now. Not end, of course, reverse end. Oh, by the way, I added iterator header of video, so if you don't have it, go edit, or it will give errors somewhere. So this part, it was a little bit complicated, so I don't know how to explain, but first we will obtain a forward iterator pointing to the element after reverse iterator's element. So I will say again auto forward iterator will be the reverse iterator, but in base, and we will decrement to the point until we get to element that we want to move, and I will say forward iterator minus forward iterator. So we will decrement, and we will check if the forward iterator will be the list and race, and it will get the forward iterator. This is we are decrementing until the element we want to move. Then again, we are incrementing the moved integer. So we know if we removed, we erased the element from the list, and then we need to reset the reverse iterator, and it will be based on the updated forward iterator. So reverse iterator will be equal to string reverse iterator function, not function, reverse iterator plus, and we will say what we are iterating. So I will say vector of string. That's what we are iterating to. And in the reverse iterator vector of strings, I guess we are missing one. Yes. We will say iterator, and we will say forward iterator. So we will be setting the reverse iterator based on the forward iterator. I don't know if this makes sense, but oh fuck, I forgot to check for the if iterator is equal to the value. So let's say Ctrl Z, and these will be all inside of an if loop, if statement, not loop. First, we will say if reverse iterator pointer to the reverse iterator is equal to the value, of course. If it is equal to the value, we are doing this. We will be checking forward iterator, getting the base, decrementing until we are getting to the element to move, and then we are erasing that iterator, and we are incrementing the removed, then we are resetting the reverse iterator. I call this iter, this is iter, so also let's call it forward iter, not iterator, so they can be consistent with each other. And yes, if that's the case, if it's reverse iterator is equal to the value, that will happen. Else we will say just increment the reverse iterator until we get to the point where we want, and we will be turning removed at the end of list remove. I mean, this was a little bit complex, but I hope you can understand the idea. Last two functions, yay. List index. So again, we will have a iterator, it list store dot find key, just like we did that with others. First, we are trying to find the key and checking if what we find is valid, and say if it is not equal to the end, we can return false in that case. And we will check for list. I'm giving a constant value because we will be playing on it. I don't want it to change after we're done playing. And list will be the second of the it, and we will check if the index is negative. So we will be supporting negative indexing. Index is less than 0. That means negative. Index will be the list size function plus the index. I'm getting the index. Typo. So, and again, we will check for if index is less than 0. Or we can also check if static cast size t. What's size t? I think it's an index integer, but size t integer. What's the difference? If it is larger than or equal to the bit size, which means we are also checking if our index is in the how to say if it's in the queue, or like to get the if it exists basically. If it doesn't, we will just return false. If it is still less than 0 after we say okay, give it the size of the list plus the index. So if you say like -5, we will say, okay, the user wants the 5th element from the end. So we just say, okay, new index will be the size of the list -5. So it will be 5th from the end. And if it is still less than 0, which is not supposed to happen, or if it is if the index is larger than the size, then we will return 0. So it means index is not in the spectrum we are looking for. And of course, this would make our value list index and return true. Because of we are giving address of the value, we can just say like that. If you were like not sure, you can always just go and search for list index, and you can see it returns a nil or string apply, which we are saying here, okay, now value is the index, so we know the value. So we go to, if you go check the handle index function, it says, okay, database index, and we give the value, and we are returning the value. So you see it, they all work in the idea. And our last list function, LSET, it's to update an element at the given position. We also have index here. Yeah, for example, when you change your message in real-time messaging app, that's also what they do. So good to know. It will start just like the LINDEX. I think I can even just copy and paste it for most of the part. Just talk about what we will be thinking. Again, we have the auto it, and we are finding the key in our list store. If it is the end, we are returning it. And we are checking for auto, not this time, no constant. No need for the constant. Also, this is constant, but we are trying to give it a value, so this will not work. We will just remove it. But step by step, mutex is in all of them. We are getting the auto it. We are checking if it is existing. If not, just false. We are getting a auto list, and it is. We are giving it the second of the it. We are again checking for the negative indexing, just like we did in the list index. This is the same. And again, here this time we are looking for if it is less than 0 or size t index is larger or equal to the last list size, which means false. And if all works fine, this is the difference between LSET and LINDEX. We are just saying list index is equals to the value. And that's all. And in the comment handler, you can see what we are doing with LSET. We are also, let me show you what we are looking for actually. Because it is just saying, okay, so we are not trying to return anything from it. So it doesn't, it's okay. And we are saying, like here we sent back the value, but here we are just saying, okay, if it is a Boolean and correct. Okay, I guess this concludes our list operations. We created a list length, list push, RPUSH, LPOP, RPOP, LREM, LINDEX, LSET. I would say they look quite fine. Next step will be hash operations, and we will be, I think just like the last one, we will be implementing the handlers first. Then we will be adding them to our comments, then implementing the bodies and blah, blah, blah. You get the idea. Okay, thank you for watching. We are mostly done. I guess next video we can do some testing before continuing with the hash operations. And then we can do the hash, then do more testing. And if it all works fine, we will have a working Redis server at the end. Thank you for watching and see you next time.